2, 3.
Okay.
It's not the fatigue, it's I have to get
Go.
flat. It's hard.
All right.
1, 2, 3.
Nice.
Come on, Walker. Big balance guy.
1, 2, 3.
Oh.
Hold up.
Okay, this is his last step, boys.
Okay, get onto the shoulders.
Now jump. 1, 2,
two,
1, 2, 3.
Okay, so today we're looking at section 11-2, a volume of prisms and cylinders. So what is volume? The volume of a three-dimensional figure is a number of non-overlapping unit cubes of a given size that will exactly fill the interior of your three-dimensional shape. So if you were to have a cube, and just picture like a Rubik's Cube, how many of the individual cubes would fill up the entire Rubik's Cube? So when we look at a cube, this is a 3 by 3 by 3 cube, so just like a Rubik's Cube. How many of the individual cubes here would make up my three-dimensional cube? Well, we see that if I were to break all these apart, I know that inside a Rubik's Cube is not completely filled with cubes, but if I were to take this, if I were to look at each individual cube, what I get on the bottom, I have a total of 3 by 3 by 3, so that gives me 9. On my second level, I have another 3, 6, 9, and then my top level here, 3, 6, 9. So really what I'm going to be doing is just looking at the area of the base. I'm just going to stack that area on top of each other, total 3 times. So all I got to do is the area of the base times the height. And that would give me the volume. So since the area of the base is 9, the height is 3, we get a total of 27 cubic units. So that's the main concept from today. To find the volume of any given shape, what you're going to do is take the area of the base and multiply it by the height. So this is volume. This is the area of the base. That's the height. So, and the other thing we got to make sure of is where area is in units squared, the volume is always going to be in units cubed. So the power of 3 here. We're going to cube our units. And the reason for that is because when we're multiplying everything together, we'll have like centimeters times centimeters times centimeters. We do it 3 times, so we'll have centimeters cubed. So volume is in cubic units. Area is in square units. So make sure you have the correct units there. So, let me erase some of this. That's the general idea. We're just going to be taking the area of our base and multiplying it by the given height. Well, we have this one other principle that we have to look over first, and this is Cavalier's principle, which says that two three-dimensional figures have the same height if they have the same height and they have the same cross-sectional area at every level, then they have the same volume. So if I take this shape, and basically if I were to push it over so it slants a little bit, like that, since the cross-section, the area of the cross-section is right there, they're the same at every single height, I can move that flat plane up and down. The two shapes here, these two shapes will have the same volume. Now the way to picture this, let's just picture a Jenga tower. Now for my Jenga tower, the volume would be how many square cubes I could fit total inside this. So that's my volume. But let's say that I were to take my Jenga tower, and if I were to kind of push it over, just make it slanted over that way, so it looks like this. Well, does the volume change? Does the number of blocks that I need to fill up the Jenga tower, does that change at all? No, it's slanted, but the space inside of the three-dimensional shape, that doesn't change. So that is this principle here. Now, let's look at how we can actually calculate the, today all we're looking at is the volume of prisms and cylinders. So in your notes, you guys have this filled out. We're only going to be looking at our prisms and cylinders today. Now the formulas here, tomorrow we'll look at the pyramids and whatnot, and cones. Now the formulas here, I'm going to try and keep it as basic as possible, but the key thing is solve for the area of the base multiplied by the height. Area of the base times height. That gives you the volume. So let's look at my rectangular prism here. Well, to solve for the area of the base, it's going to be capital B. For a rectangular prism or a square prism, it's just going to be the length times the width. That will give me the area of the base. I'm going to put a little line here to separate these. Well, for the volume, jumping over here, the volume is going to be equal to the area of the base, capital B for area of the base, which is length times width. I'm just going to multiply it by the height. That's it. Let's look at this one here. Well, what's the shape of my base here? The shape of the base is a pentagon, and it's a regular pentagon. So if you guys remember, to find the area, I'm going to do capital B for area of the base. The area of a regular polygon would be 1/2 A in S. Remember that A is my apothem, N is the number of sides, S is the side length. So everything that we just did in chapter 10, calculating the area of pentagons, regular hexagons, regular octagons, that's all going to come back. So we will be using a trig possibly to solve for the apothem. So everything we just did in chapter 10, we're still using it. Now to calculate the volume of this prism, this hexagonal prism, right prism, I'm just going to take the area of the base and then multiply it by the height. And that gives you the area, or the volume, sorry. Now we're going to do some examples soon, but let's look at our cylinder. Well, what shape do I have for the base? That's terrible. Well, let's say, even though it's at an angle, it doesn't look like a circle. If I were to look straight down, we'd have a circle as the top and bottom at both bases. So how do I calculate the area of a circle? Area of the base is pi times radius squared. So that would give me the area of my base. To calculate the volume, take the area of the base, multiply it by the height. Now the area of the base here, I could substitute this and rewrite this as pi radius squared times the height. Now, let's go and look at that. That's how you solve for the area. I keep saying area. That's how you solve for the volume of your shape. But now let's go ahead and look at these two terms here, the lateral area and the surface area. So what is the lateral area and what is the surface area? So the lateral area, just a second, let me add this really quick. Let's just go ahead and look at the shape here. So the lateral area is the area of each individual face going around my shape and then add all those each individual areas together, and that will give me the lateral area. So lateral area is just the area going around the side of my prism. That's what the lateral area is. Now the surface area is where I take the lateral area, the area going all around the side, plus both bases. So the surface area is the total area on the surface, just like it sounds. The total area on the surface of your shape. So you're just going to be calculating all these shapes individually. You could do it that way. I calculate this area plus 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 this area. I mean, you could calculate each area individually, both bases and all the sides, and add them together to get the total surface area. But let's do things a little bit easier. The easier way to do this, to calculate the lateral area, all I'm going to do is calculate the perimeter of the base, and then I'm going to multiply it by the height. So the lateral area, the area going all the way around here, all I'm going to do is calculate the perimeter of the base, and for a hexagon, a pentagon, whatever regular polygon you have, P is equal to the perimeter is equal to the number of sides times the side length. I'm just going to multiply it by the height. Now the easy way to calculate the perimeter, if you're not sure, just add up the sides of the base. There you go. So P is equal to the number of sides times S for if it's a regular shape. If it's a rectangle here, just add up the sides of the base and then multiply by the height. So that gives you the area going around the shape. Now to calculate the surface area, the lateral area, and both bases, the surface area is just going to be equal to the lateral area plus 2 times the area of the base. Since I have the top and bottom base, I'm just going to take both bases and add it to the lateral area. So for a cylinder, I don't have perimeter. The length going around my circle, that is called the circumference, which is 2 pi r, or I could use pi times diameter, whichever one you prefer. So to calculate the lateral area, all I'm going to do is take the circumference, just like the perimeter, times the height. For a circle, the perimeter, quote unquote, is the circumference. So lateral area is equal to the circumference times the height, which I could substitute 2 pi r times the height. For the surface area, I'm going to take the lateral area plus 2b. I'm going to take both areas of the bases and then add it to the lateral area. And that will give me the total surface area, the total area of all the surfaces. So these formulas, this one here, these are both the same. Make sure you memorize those. So the key ones to know is that the lateral area is equal to the perimeter of the base times the height, or L is equal to CH. Surface area, L plus 2B, and the volume is equal to the area of the base times the height. Those are my key ones. You just have to know which shapes you're dealing with too, which cylinder or prism. Let's do a few examples. So when solving for, this is the type of stuff you'll have on the tests and quiz and homework. You have to solve for the lateral area, you have to solve for the surface area, and the volume. But even before we do that, I would say the very first thing you should do is always calculate the area of the base, big B. What's the area of the base? Well, for my prism here, the area of the base is length times width, 11 times 5. So the area of the base here is equal to 55 feet squared. Now let's calculate the lateral area. But to calculate the lateral area, I need the perimeter of the base. So the perimeter of the base, I have this side, which is 11. I have 11 on that side. I have 55. I have 5 and 5. So I get 11 plus 11 plus 5 plus 5. We're going to do 2L plus 2W. I'm just doing it the straightforward way. And the perimeter of the base, that gives me 32 feet. Now to calculate the lateral area, it's the perimeter of the base times the height, which gives me 32, times the height, which is 8. So I get the lateral area of, let me erase some of this. Um, 32 times 8 gives me 256 feet squared. Now it is area, so make sure that you have units squared. Now let's calculate the surface area. The surface area is equal to the lateral area plus 2 times the area of the base. That gives me 256, which is the lateral area, plus 2 times the area of the base, which the area of the base we did at the beginning. That was 55 feet squared. So the surface area is going to be equal to 366 feet squared. Now still feet squared because it's still area. Area is units squared. Now let's calculate the volume. The volume is equal to the area of the base times the height. Well, the area of the base is 55. The height is 8 feet. So that gives me a volume of 440 feet cubed. Make sure you cube the volume. So that's how you calculate the lateral area, surface area, and volume of my rectangular right prism here. Now I suggest that you pause the video and try and do this one on your own. This is a cube. So remember what we know about a cube. And then try and calculate the lateral area, surface area, and volume. Alright, let's do it together. Calculate the lateral area, surface area, and volume of this cube. Let's start with the base, area of the base. Well, the area of the base, this is 13, so 13 times 13, or 13 squared. That gives me 169 meters squared. Now on the test quiz, I'll probably ask for the area of the base, and I'll ask for the perimeter probably, so make sure you know how to calculate them. Now solve for the lateral area. Lateral area is equal to the perimeter times the height. Well, what's the perimeter? Well, I have 13 plus 13 plus 13 plus 13, or 4 times 13. Well, that gives me, 4 times 13 gives me 52. Now the height is also 13, so the lateral area is equal to 676 feet squared. Sorry, meters. Meters. Meters squared. Surface area is equal to the lateral area plus 2 times the area of the base. So that gives me 676 plus 2 times 169. And that gives me a surface area of 1,014 meters squared. And that's my surface area. Now, the homework tonight, you guys will have to calculate the lateral area and surface area, so make sure you check RenWeb for which problems you're supposed to do it on, because you're not supposed to do it on all of them, but you will have to do some of them. I'll dock you guys points if you don't do that, so make sure you do that. Volume is equal to the area of the base times the height. Volume is equal to 169, which is the area of my base. I start with that. The height is 13. The volume is equal to, that gives me what? 2197 meters cubed. meters cubed. Now, a quick note with your cube here for the volume, you could just do side length. Oops. Cubed, because with the cube all the sides are the same, so it's 13 times 13 times 13, or just 13 cubed. So that's a little trick with the cube. You get a few different identities there. Now let's look at do a couple more. Let's look at the triangular. Actually, you know what? We should probably do it. Let's do the triangular right prism. Now just notice that this is on its side. It's flipped over on its side. So the base, these are my bases, both triangles, and the height is actually this 8 yards here. So let's calculate the area of the base of my triangle. Capital B is equal to 1/2 times the base times the height. So the base is 6, height of the triangle is 7. So I get 1/2 6 times 7, which gives me the area of the base is 21 yards squared. Lateral area is equal to, and we're not going to do the cylinder today, so I can get rid of this. Give me a little bit more room. Now the lateral area is equal to the perimeter of the base times the height. Well, the height is 8, but what's the perimeter of the base? So I need to add up all those sides here. Well, I have the 6, but what's this side length here? Well, notice that we have a right triangle. The height is 7. Right here, that's a 3. So I can use the Pythagorean theorem to solve for the hypotenuse. So using the Pythagorean theorem to solve for the hypotenuse, that gives me, what is it, 7.6. So the perimeter of my base is equal to 7.6 plus 7.6 plus 6. So 7.6, 7.6, and then 6. And that gives me, perimeter of the base is, let's see, 21.2. Yeah. Yards. So I get 21.2 times the height of 8. So my lateral area is equal to 169.6 yards squared. Let me double check that really quick. Alright, now let's solve for the surface area. The surface area is equal to the lateral area plus 2 times the area of the base. That gives me 169.6 plus 2 times 2 times the area of the base, which is 21. Looking back over here. That gives me a surface area of, when I do 2 times 21 plus 169.6, gives me 211.6 yards squared. So here's my lateral area, here's the surface area, and let's quickly calculate the volume. The volume is equal to area of the base times the height. Well, the area of the base is 21, the height is 8, so that gives me a volume of 168 yards cubed. Don't forget units cubed for volume. So that's how you calculate the volume, lateral area, and surface area of those three shapes there, three-dimensional shapes. Now we'll go through a couple more really quick. Let's say you have a shape like this. Notice that I have a pentagon again, but I don't have I need to calculate the area of this base. But to do that, I need the apothem, which I don't have. So to calculate the area, I'm going to be using the formula area, which is the area of the base. I'm going to use B for area of the base. This is 1/2 A N S. A is the number, or A is the apothem, N number of sides, S side length. But I don't have my apothem. So to do this, this is in the book, example C in the book from 11-2. I'll kind of walk you guys through the steps of how to solve this really quick. So first we need to solve for the apothem. Now I already have the so there's my, this would be my central angle. Now I already have half the central angle. That's already given to us. So to solve for the apothem, I'm going to use my trig function right here, opposite over adjacent. I'm going to swap these two, multiply by 8 and divide by tan 36. And that will give me the length of the apothem. And then just in the book here, just so you guys know, they didn't actually get a number. And P is just the number of sides, it's the perimeter of the base, so number of sides times side length, which is 25. So when you do this, you plug this all into your calculator. That will give you the area of the base, which is so here again, you don't have to use your, you could use your calculator to solve and get a decimal number, or you could just keep it like they did here. I'd prefer you guys to actually get a decimal number. I think it's a little bit more clear. But they multiply by the height, which is 7, and that gives you the volume of 301.1 meters cubed. Now, you guys do have a couple of questions where it's like the change in dimensions. And remember, it's going to be the same thing that we did previously. So change in dimensions. All you're going to do, if you're looking at a volume, you just calculate the original volume, put the new volume on top, and just whatever ratio that gives you, that will be the change in the dimensions. So really quickly, let's say you calculate the volume of your shape, your original shape. And say the original volume is, I'm just going to throw out a number out there. Let's say it's 4 meters cubed. Let's say that the new volume is, let's just say it's 12. I'm just making up numbers here, 12 meters cubed. What's the change? Well, the change would be, those cancel. 12 divided by 4 is 3. So the new volume, or the new shape, would be, new volume is 3 times larger. So the same thing that we did previously, and a lot of times those numbers can cancel out. But you only have a couple of questions like that. And I might do a whole nother video later if there's confusion. Anyways, the video is getting kind of long. I will have a few other examples up later on a review day. I'm going to give some more detailed examples of different things you can solve for before the quiz, which is on Thursday. Email me if you guys have any questions, and I'll talk to you later. Bye.